I work at LSE with Davide Faranda. I'm just started the postdoc. And today I'm just giving a brief overview of the project I'm involved in, which is PowDev, and is a project on energy and essentially on the strategic power systems development in future climate. And it's a project that is a part of a PEPR that is called TASE on the energetic systems, and it's a multidisciplinary collaboration among different institutions. So we have Centro Supelec, where we have Anne Barros, that is who is the leader of this project, then Università Grenoble Alpes, UVSQ, IRIA, and CNRS. And we will, since it's a national project, we will mainly work on France, but since we are dealing with the energy and since the electricity market is really interconnected in Europe, we will focus on case study in France, but we will extend obviously our analysis in overall Europe. It's just an overview because we didn't started working it, so we have just a general idea, and we will have the kickoff meeting, I would say, in a few days. So we will start collaborating on it. So the main idea is of the project is identifying in the end a set of supporting tools that are built from the analysis of the whole change, so from extreme events in present and future climates through the power grid modeling, considering renewable energy sourcing integration, and considering also socio-economic scenarios. And so the two main objectives are the first one that is simulating and characterizing the scenarios of blackouts, and ending up with the quantitative optimization tool for resilience of the power system. And we will have a coordination group, which is led by Centro Supelec and Anne Barros and Alicia Bassier, who gave a talk this morning. And this package is about the scientific coordination, so to ensure that all the packages will communicate and we will have a coherent overview of the whole project. And then I can start showing a bit the whole packages. So there will be a part on extreme events that has a lot of link with what Freddy, Henri, and Sebastian talked these days. So we will start with this package is led at LSE by Davide, me, Adrian, and another PhD student. And the idea is to identify first historical extreme weather events who triggered major blackouts, and we will work on dry events, so droughts, heat waves, and cold spells and low wind. And the wet events, Adrian will specifically work on the thunderstorm, leveraging high resolution database like from satellites and convection permitting models. So the second part will be the evaluation of the capability of climate modeling in reproducing the extreme events, and obviously considering bias correction and downscaling if we are dealing with global climate models. And we will work on the probabilistic forecast. Probably we will work together somehow on rare algorithm for rare events algorithm for the forecast of extreme events. And we are thinking also to use storytelling to identify some possible scenario black swans that cannot be observed from stochastic generation, statistic generation. The output of our work package will be the input of the working package 2, which is carried on in Università Grenoble Alpes and the laboratory GD Lab, where they will work on the power grid modeling, so the physical constraints and considering the cascading failure of the distribution systems. So they will work definitely on this, using as input the extreme events that we will give them. And finally, there will be a part on the optimization tools. So this is again supervised by Central Supelec. There will be actually two main axes. The first one is the one that will be carried on in Central Supelec, where they will work on identifying the operational strategies for resilience in power system, like load shedding or I don't know, spillage of renewable energies. And the second one is the second axis that will be led in area. It's more on the optimizing the investment decision, so the centralized storage, production, and structure of the network, and they have more a mathematical background, so they will work on robust optimization of the investment decision. And finally, the last part is on identifying the economical and societal scenarios. So this part will be carried on in UMISource, in Université Paris-Saclay, and there are three main issues that they will work on. So the building of socio-economic scenarios to assess the challenge of the integration of renewable and massive renewable energy in the power system. They will identify and characterize the stakeholders that are involved in deployment of renewable energy. And finally, the last part is on the impact assessment, so the evaluation of the socio-economic impacts with respect to power system blackouts with a short-term and long-term perspective. So that's the general idea. We will probably have to work with you because it seems that we have some points in common. To summarize, the contribution of the project will be on detecting climate change scenarios in the analysis of resilience of power system. They will in the part of power modeling, they will consider cascading failures in the integration of renewable energy sources. There will be an evaluation of the societal and economical value chain, and finally a part on the optimization of decision and policy strategic tools for design and operation in power system. And an important thing is also that we will aim to identify some policies from the optimization tool that we will identify, and we will hopefully end up with some policy reports on the results. Okay, that's all. Thank you.